Okay, so we are now being recorded, and if you have any questions, there is a chat box and there is a Q&A box that I will check periodically throughout the webinar to answer any questions along the way. So, feel free to type whatever questions you have. And the notes for this webinar are available. I have my email address at the end of this, and if you're one of my students, I'll put it in the Blackboard, and if you have a different instructor, I'm going to be emailing this out to the instructors as well. So you don't have to frantically write whatever you see on the screen because I will have the notes available for you. It's a PDF document that you can use. So we'll go ahead and get started, and I'm just checking to make sure no questions as we get started. So this webinar is going to basically cover these two main topics. We're going to look at using truth tables to determine the validity of arguments and then recognize common argument forms. So, and we're really going to be doing both of these together throughout the webinar. So truth tables help us determine the validity of an argument that is more complex than an Euler diagram can handle. I know we've also studied Euler diagrams in this course, and you may wonder, well, we have that to determine whether an argument's valid or invalid, but not all arguments work with Euler diagrams. So Euler diagrams really have the quantifiers all, some, no, that kind of thing, but not every argument is set up that way. So we use truth tables to look at the structure of an argument. It's just another tool we have to determine if an argument is valid or invalid and if the reasoning is logical. We're looking to see if there are holes in the argument along the way. So since the words and the content of the argument can get in the way of this, we translate the argument to symbols in truth tables. So what I mean by that is we can sometimes, for instance, if the argument is about ice cream, while we're reading it, we're thinking about ice cream, and that distracts us from the actual logical flow of the argument. And so what we do is we take the words out and translate it, the whole argument, to symbols so that when we're looking at the argument, we are not thinking about ice cream. We're thinking about just the structure, and that's it. Now, a valid argument can have a false conclusion, and an invalid argument can have a true conclusion. And what I mean by that, I have an example here. For instance, if the argument has the conclusion, I don't have the whole argument, but just say the conclusion is February is the second month of the year, which is true. But if the statements leading up to this conclusion do not support this conclusion, then it's not a valid argument. It's invalid. So we're not looking at just the conclusion. We are looking at the conclusion along with how the words leading up to that conclusion, how they support the conclusion. So that's really what we're focusing here. We're not really focusing on whether the conclusion is true or false. Okay? We're analyzing the entire argument, not just the conclusion. So I've laid out some steps that we're going to follow with some examples for doing this, making the truth tables. First of all, we're going to assign a letter to represent each component statement in the argument so that we're going from the words to symbols. So letters will represent some content. Then we're going to take, now an argument is laid out where you have premise statements, and sometimes there's more than two, but we're going to have two, and then we'll draw a line, and then the conclusion will come under the line. And the premise statements are supposed to lead up to the conclusion. Okay, so we're going to take the content and write them as letters, and then we're going to take each premise statement and the conclusion and write those symbolically with those letters, with some other symbols thrown in. And then we take the whole argument and write it as one statement with symbols. And we use this format, we're going to be using this format over and over again, where we have if, premise statements and premise statements, then the conclusion statement. So this is another statement right here. And so we're going to use the and. We'll be using the symbol for and. We'll put the and between the premise statements, and then we're going to put the arrow leading up to the conclusion. And so that's basically how we set it up. And then once we have that written, we do the truth table for that statement. And if it's a tautology, then it's valid. Now, otherwise it's invalid. A tautology is when the final column that you complete has all true. It has to all be true. That means that no matter the truth values of each premise statement, the argument is valid. The whole point of a truth table is where every row has every possible situation with whether the statements are true or false. And so we're listing the possibilities when we make a truth table. So if at the end of it all, everything is listed as true, that means all of the possible real-life situations that come about with this particular argument, it has a valid conclusion. Okay. And we're going to be doing examples of all of this along the way. Okay. I'm just checking to see if there's any questions. I don't see any so far. We haven't really done any examples yet, though. Let's take a look. Oh, yes, it only takes one false in that last column to make an argument invalid. That means that there is a situation where there's a hole in the reasoning, and all we're looking for is that little hole. It's just one false is all you need to say the argument is invalid, meaning that there is a flaw. It doesn't have to be a big flaw, but there is a flaw in that reasoning, and so it is not logically sound, and we deem the entire argument invalid. The only way it's valid is if there's no little flaw, no little hole in the reasoning. Okay, so let's do an example. If I have a car accident, then I will need to repair my car. I had a car accident. And so the line here is separating the premise statements from the conclusion. So here's the first premise statement, here's the second premise statement, and then there's the conclusion. So first premise statement, if I have a car accident, then I will need to repair my car. Second premise statement, I had a car accident. Conclusion, I will need to repair my car. Now, I need to caution you against reading the argument and making a decision based on just reading it to determine is that valid or invalid. You do not want to skip the truth table altogether and just look at it and go, oh, it's valid or oh, it's invalid. Okay? It's really important that we do the truth table for each one of these. So step one is to assign a letter to represent each component statement. So we could let P be, I have a car accident, Q, I will need to repair my car. So with that, everywhere there's I have a car accident, there's right here and right here, I'm going to take out those words and put the letter P. And everywhere there's I will need to repair my car, which is here and here, I will take out those words and put in a letter Q. Now also, for the if-then, we have the arrow that we're going to be using. So let's see what this looks like. So if I have a car accident, I will need to repair my car. Looks like that, P arrow Q. I had a car accident, that's P. So those are the premise statements. That's what we write before we get to the horizontal line. Then the conclusion, I will need to repair my car, is translated Q. So the entire argument now looks like this. Notice that because we took out the words and put symbols, we're not distracted by thinking about cars. Otherwise, when we're looking at it this way, we look at it this way, our mind is thinking about cars and car accidents, and it's distracting us from the structure of the argument. So we look at it this way so that we are not thinking about cars and car accidents, and we're just looking at the structure of the argument to determine if there are any flaws in the reasoning. So we have this now, and step 3 is to write the entire argument is one long sentence, basically. If premise and premise, then conclusion. So the first premise statement I put right here, and then the second premise statement I put right here, and I put the and symbol. Here's the and symbol. The and symbol goes between them. And I do use brackets to put these together. We do want to always put brackets, so we have the brackets and the and in between. And this if-then can be translated to an arrow. So in the end, we have this where we need to take that. The argument now is in this one logical statement that we need to do a truth table with, and the truth table will then determine for us whether the argument is valid or invalid. So the entire argument now is in this row right here. I'm going to pause to see if there are any questions, and I don't see any questions. Okay. So we're going to do a truth table now with that argument, and if it's a tautology, it's valid. Otherwise, it's invalid. Okay, and so just like in algebra, you want to do what's inside the parentheses first. So this is where we're going to focus to start with. And we're going to use our rule for the conditional, if P then Q. For the conditional, the only time you write false is when you have this situation. This is when it's false. Otherwise, it's true. So we just use that to go down the column. That's true. This is the false situation. This is true. This is true. So it's just the second row that would be false inside the parentheses. Okay? So now we have this. And the next thing that we need to do is inside the brackets. So that is this and. The and comes next, okay, because we worked inside the parentheses. And I think my screen just went black. Hold on just a second. I will bring it back up. Thank you for your patience. Should be coming up shortly. The problem is fixed. I just need to bring it back up. my computer, it completely shut down in the middle of all of this for no apparent reason. You gotta love technology. And it's taking a while to come back up. Hello, I want to apologize for that. My computer shut down for no reason. I don't understand. So I don't know. I'm so sorry. I don't think you guys can see my screen. No, you cannot see my screen. Okay. Let me try something real quick. I promise to come right back. I am so sorry. I don't want to end the event. I'm trying to leave the event, and it's not letting me leave the event in order to come back so I can share my screen. Sorry. That's a really big sigh. Okay. I will come right back, I promise. So sorry. It's not letting me come back in and share my screen once I left. Okay, so what I'm going to do, I hate to do this. Yes, I'm going to close this out and I'm going to restart. And we're still going to have this tonight. It'll just be a little bit shorter. But I'm going to close out the session and then I'm going to restart it, so you'll have to rejoin. It won't let me join without to be able to share my screen, and since I had to leave because my computer shut down. So let's start it. Yeah, let's going to reschedule in, let's say, 5 minutes. Just come back in 5 minutes because it'll take me a little bit to open it all back up again. So I'm just going to close it out and get it right back open again. So I'm going to have to end the session and then restart.